Yeah, good evening students. Today we will discuss motion, types of motion, distance and displacement. Okay, let's start the motion. An object is said to be in motion if its position changes with respect to the time. The important thing is the change, its position is changes. Position is changes with respect to the time. When a body changes its position with respect to time, then it is called a motion. The process is called a motion. Now, types of motion. Basically, there are three types of motion. One is linear motion, one is circular motion, and another is a vibratory motion. Right? What about linear motion or translatory motion? When the body moves along the straight line, then such type of motion is called straight line motion. Motion is called translational motion. Right? For example, when a bus moves around the straight road, this type of motion is called linear motion, right? Now, what about circular motion or rotationary motion? When a body moves along a curved path or moves a circular path around a fixed point, right? For example, the earth moves around the sun along the fixed path, right? Now, what about a vibratory motion? Vibratory motion is the to and fro motion of a body about a fixed point, right? For example, the motion of the pendulum. Pendulum, what happened? To and from fixed from the middle of the bob, it move around the fixed points, right? So such type of motion is called vibratory motion. Next, we will see the displacement and displacement. Distance and displacement, right? Now, what about distance? Distance is the actual path traveled by the body, by a body, right? By a body. What it means? Actual path, yeah, total path. Okay. For a motion, when a body moves, what the total path traveled by the body is called distance, right? Now, what about the displacement? Displacement is the shortest path, or you can say like this: it is the shortest distance traveled by a body from a initial and the final point. So what we have to do? We have to calculate displacement by only initial and the final points, right? If initial and the final points are same, what happens? If initial and the final points are same, then displacement is 0. Then the displacement is 0. Let us consider an example. A body moves from A point, then it moves to point B, and then C, and finally it comes to the B point. Now somebody says find out the displacement. So what is the initial point? That is A, and what is the final point? That is B, right? So we have to calculate the distance between A and B, right? So this is called displacement. Let us example. This is 5 km. We consider this AB distance is 5 km, and this BC distance is also 5 km. Now, what is the total distance for this motion? Now the total distance for this motion is 5 plus 5, that is A or B distance is 5 km, B and C distance is 5 km, and C and B distance is also 5 km. So total distance is, you can say, 15 km for this example. Now what about displacement? We have to consider initial and the final points. So what about initial and final points? This is A and this is B. So what is the distance? Shortest distance between them is 5 km. So for this example, we have displacement 5 km. Right? So we can do distance and displacement like this. We also consider more examples like clock examples for this finding out the distance and displacement. Okay. Okay. Thank you very much.